Section 7.5, Properties of Logarithms. So you've seen that an exponential function is one that has the variable in the exponent. And so logarithms is the inverse property, and they're going to allow us to take the variable out of the exponent. Before we can start using logarithms to do that, we need to learn the properties of logarithms. So there's basically going to be four properties that we're going to be using in this chapter. The first one is the log equality property. And so if I have the log base b of u equal to the log base b of v, then u has to equal v. And so this is similar to the lines of if I have 2 to the x equals 2 to the 3, it's somewhat intuitive that x has to equal 3. So this log equality property falls along those same lines. Be assured, though, that we're not dividing both sides by the log base b. Dividing by the log of a base has no meaning. The next property is the product property. So if I have the log base b of two factors, I can decompose that into the log base b of the sum of each of those factors. Or I could compose them. So we need to remember that when we are dealing with these properties, they go both ways. We can decompose or compose them. The next property is the quotient property. And along the same lines as the product property, if I have the quotient of a log, I can decompose that into the difference of each of those, the numerator minus the denominator, provided that v is not equal to 0. And finally, also remembering that that property also goes both ways. And finally, the power property. This is the property that's going to allow us to take the variable n out of the exponent and bring it out in front as a factor. Then we will be able to divide both sides by the log base b of u. So in that case, we would be able to divide both sides. This is probably going to be the most useful property for us in this chapter. So let's put some of these properties to use. I'm going to be doing half of the problems that are in the note packet, not necessarily every other one, but I will be doing half of them, and would encourage you to either pause the video if you understand the property and do the one that I've skipped, or go back after we've covered the notes and do them. Either way, we'll be starting class with the problems that I haven't done in the note packet. So in this first problem, log base 7 of 50 equals the log base 7 of x plus 8. Well, I have the log base 7 equal to the log base 7, so that means 50 has to equal x plus 8. And now I can just solve that equation for x, and I get that x equals 42. Moving now to number 4, we can see in number 4 that we're adding two logs together. However, we also have to notice that they are in fact the same base, so we can rewrite this as the log base 4 of the product of those, which is 3x times x, which would be x squared. And then of course it's still equal to the log base 4 of 151. Now, since we have the log base 4 of a number equal to the log base 4 of a number, we can set those equal to each other, and now we can solve this for x. Dividing both sides by 3, and taking the square root of both sides, we're going to get x equals 7.0946. We're not going to use the negative root. This is a good place to note that you can't take the log of a negative number. So that, therefore, we're just going to be dealing with the positive root. Moving now to number 5, this problem is going to demonstrate the quotient property. So we're going to be subtracting two logs of the same base, which means we can rewrite the left-hand side as the log base 2 of 20 over x, and of course that's still going to equal the log base 2 of 9. Now, since we have the log base 2 equal to the log base 2, we've got 20 over x equals 9. Solving this for x by getting x on the numerator out of the denominator, dividing by 9, we have x equals 20 over 9, or 2.2 repeating. And let's do one more basic problem before we move into a couple that put some of these properties all together. So now we have the log base 2 equal to the log base 2, but we've got this 21 out in front that's being multiplied by the log. So we're going to use the product property backwards, and we're going to bring that 21 up into the exponent. Rewrite that as log base 2 of x to the 21st. That's equal to the log base 2 of 100. Now, since we've got the log base 2 equal to the log base 2, we're not dividing both sides by the log base 2, but by the equality property, we've got x to the 21st equals 100. Hopefully you know how in your calculator to take the 21st root of a number, because in order to get rid of that exponent of 21, that's what we've got to do. When you put that into your calculator, hopefully you'll get 1.2452. You really should make sure that you know how to do that, and if you don't, make sure you ask tomorrow in class. Alright, now let's do one that puts all sorts of stuff together. So in this problem, we've got a number that's being multiplied by a log. We've got the addition of two logs. And on the right-hand side, we've got the subtraction of two logs. So first of all, kind of like the properties of order of operations, let's take care of that exponent first, because it's only on the log base 7 of x. So we're going to bring that 2 up front as the exponent, and we still have the log base 7 of 5. On the right-hand side, since the subtraction is the only thing that we got going on, we can take care of that and rewrite that as the log base 7 of 100 over 5. Now on the left, we can rewrite the addition of two logs as the product of that single log. So log base 7 of 5x squared. On the left, 100 divided by 5 is 20. Now that we've got the log base 7 equals log base 7, again, we're not dividing both sides by the log base 7. I'm just stressing that we've got the same base. Now we can solve this for x and take the square root of both sides. X, the square root of 4 is plus or minus 2. But again, remember that we can't take the log of a negative number, so we're going to restrict this to just positive 2. Now we're going to skip to number 12. And for some reason people see fractions and they get intimidated, and there's really not anything to be intimidated about. On the left-hand side, really all we've got going on is the addition of two logs. So we can rewrite this as the product of each of those logs. And on the right-hand side, all we've got going on is the number that's being multiplied by the log. So again, we've got the product of 1 over 2 times x over 2. And we're going to bring that exponent up in front. So we've got the log of 6 squared. Again, now we've got the log base 8 equal to the log base 8. So we can set those product equal to that exponent, multiplying both sides by 4, and we get x equals 144. And this last problem, though, if you would like to study and try to memorize the change of base formula, by all means, go ahead and do that. Otherwise, I'm going to try to show you how this change of base formula works. And so even if you forget the change of base formula, then you can always do one of these problems this way. So we need to determine what log base 7 of 31 equals. Well, I'm going to let that equal x because I don't know what it equals. Now if you remember, I'm going to do that trick that I call the loopy thing. So I'm going to take 7 to the x equals 31. And now this is exactly why we're learning logarithms. We've got the variable that's in the exponent. So to get it out, I'm going to take the log of both sides. Log base 10 of 7 to the x equals the log base 10 of 31. The reason I'm doing the logarithm is to bring the exponent out in front. So now I have x times the log of 7 equals the log of 31. And as I mentioned, we're dealing with base 10. The reason I'm doing that is because the log button on your calculator is base 10, so that would be the most useful logarithm to divide by. Dividing both sides by the log base 10, I can put the right-hand side in my calculator, and I get x equals 1.7647. If you think you have a grasp of what we've done in these so far, I would encourage you to go back in the note packet and do the problems that I skipped. And either way, we'll be starting the class with these. If you have any other questions, please make sure that you write them down, and we will also address those in class. And we'll see you tomorrow.